it's a real pleasure to be here. I've been honored to be the first cryptocurrency company representative in this forum. I think that we all know about cryptocurrency already, some, and you know the financial crisis happening as we speak right now, also affecting dramatically the cryptocurrency world. But anyhow, the challenges are quite amazing and extensive, and my intention here is to give you a glimpse of what a blockchain is, what a cryptocurrency is, and then we'll talk about the challenges, data science challenges, and the potential. Just a quick introduction about myself. Just a quick introduction about myself. So, as William said, I'm the CTO of PowerSwap ever since January this year. I have over 25 years of experience in the IT market. I'm fresh to blockchain, but during my entire career, I've been juggling around from different companies and different verticals and delivering big projects around the world. So it's nothing new to me. It's a pleasure to learn new technology and new potential. I'm a cloud and data expert. Ever since the inception of AWS in 2006, I've been helping companies from startups to enterprises to do a transformation into the cloud, to understand the benefits and to optimize costs across. Same goes for data pipelines until AI and MLOps included. I've been doing and juggling between technical positions, hands-on coding until this very moment, and business positions as well. My last position was the regional manager for a cloud reseller company in Israel, counting about 11,000 people. And actually the reach to Portugal for me was part of that experience, and I've just fell in love with this place. As William said, I'm originally from Israel and I'm currently based in Lisbon, and hopefully next year I'll be speaking in Portuguese. So what's the agenda for us? Let's first of all talk about blockchain. What is blockchain? What are the benefits of blockchain? Why do we need blockchain? Then we'll talk about the data science challenges and the potential. And eventually, I'll try to convince some of you online or here what's there for you. So what's a blockchain? A blockchain comes with a lot of promises around trustless. When I say trustless, I don't mean don't trust it, but it doesn't require any trust. When we deposit money in our bank, we trust our bank that it keeps the money. When I work with Revolut and I have an account there, all Revolut maintains for me is just a list of records. I paid that and I got money from that. But basically all my money is staying in a big pool shared with a lot of other people. If somebody would be able to delete a record from my account, or if the bank decides to do some data migration, something fails unintentionally, that could affect me dramatically. When we talk about trustless, we mean that nobody is able to push a button or to change my records or anything like that. Secured, we need security across the board when we talk about our banks, when we talk about our utilities companies, when we talk about our home, and same goes for blockchain. When we say secured, we really need to make sure that only the identity that owns the account is able to move or change state, move tokens, move coins, do whatever. It's distributed. Today, if I consider any company, they have maybe multiple data centers. Maybe they are using cloud services in different regions, etc., for high availability, for scalability reasons, for latency reasons. But when we talk about distribution in blockchain, we talk about no single ownership. We talk about consensus of many thousands of machines running around the world and doing one thing to protect the historical data and every state change recorded and registered in the blockchain for good. Non-custodial. When we talk about custody, we talk about who's owning the money, who's holding the money or the assets that I'm giving to that entity as part of a service agreement. Yeah. So when I work with Revolut, my money is sitting actually there. If Revolut bankrupts or, I don't know, they didn't put my money in escrow or the federal bank is not securing my entire money, I might lose some money. When I talk about non-custodial, it means that only I have access to that money. Nobody can take it. It doesn't matter who is going to just liquidate or disappear or completely collapse. Unstoppable is another fact that is rising from the fact that it's distributed and ran by many different owners, thousands of owners, tens of thousands of owners, so nobody can stop it. It's not like I can just decide that I'm taking off the entire network for a maintenance, or I just want to change history. This is no longer completely right, because if you've heard about the hack just less than a week ago, start of this week, for Binance. Binance is a publicly traded company, centralized exchange for cryptocurrencies, and they had a hack that was right about $600 million. And actually, they are not completely decentralized, and what they've done is just took off the network, and now they're planning a fork of the network because of that hack in order to reverse history. But this shouldn't have happened in a real distributed blockchain. It's immutable. So once a state has changed and once it's written to the ledger, nobody can rewrite the history. If you heard about the mining stories about Bitcoin mining and all these mining rugs that are running around the world, and they are competing for fees, but basically what they are doing, they are solving mathematical puzzles. And those mathematical puzzles are sealing every single transaction, every single block, sealing the ledger from any change, so that as time goes by, it will be harder and harder to regenerate the history, because I need to solve puzzles that are just very hard to solve. And as the blockchain advanced and I have more blocks to reproduce, if I want to change a transaction back, that wouldn't be possible. All this technology is backed by a lot of cryptography, so a lot of cryptography concepts are embedded into the technology, and a consensus algorithm that enables these distributed nodes or computers to agree on what has occurred. So just to give you a glimpse of blockchain, when we talk about blockchain, what do we talk about? So a blockchain is, as you hear, a chain of blocks. A block is just a unit that contains multiple transactions. What is a transaction? A transaction is simply a change of state. Yeah? When I decide to pay my CPA and I do a money transfer, the bank updates double booking The bank updates the two accounts records, okay? It will deduct that amount from my account, and it will deposit that amount on the CPA account. A transaction in blockchain depends on which blockchain we're talking about, because the blockchain technology has been advanced. There are many permutations of blockchains. If we talk about Bitcoin, that all of us have heard about, that was incepted in 2009, this is, I would say, like the primitive blockchain that enables basically state changes of traveler checks. UTXO is a certificate that I hold some amount of some asset. William? Can I get some water? Can I get some water? Yeah. So UTXO or travel checks in Bitcoin are simply a certificate that are transferred and moved between different parties, okay? And Bitcoin doesn't allow any more than that. And using that, I can exchange, for example, I have a UTXO of 100 Bitcoins, and I want to give you 3. I will deposit to the system the 100. I'll tell the system to deposit to you the 3 Bitcoin, and the system will reproduce a new UTXO, a new travel check with the remaining, which is 97. When we talk about more advanced blockchain technologies and Ethereum to start with, that was incepted in 2015, Ethereum is already a programmable blockchain. What it means is that I could have changed, thank you so much. I could have created any set of rules and programmed them and deployed them into the chain, and they are immutable. Once I deployed the program into the chain, this program cannot be changed, and it will always follow the set of rules that were programmed into this program. So using these programs, I could do in a transaction, in a set of state changes, everything that comes to mind. So if I was wanting to implement a lottery program, I could have developed a smart contract, it's called the smart contract, that would basically collect money from players and eventually will choose one of the players. Randomness is not really available in blockchain because we need everything to be deterministic. When we think about blockchain, every node in the chain has to reapply the same set of state changes and to recalculate the same state changes and to come to the same conclusion about the cryptographic validation of each transaction. So we cannot put randomness into that. We need everything to be deterministic, that every node, every participant will be able to revalidate the same data. So for the lottery example, we could have relied on some external sources of some kind or some random, only the X depositor into the contract will be the winner or something like that. So a transaction, as I said, is simple coin transfer. It could be a mix of different things. Let's say that I want to transfer to you, I have Ethereum and I want to transfer to you Bitcoin. How do I do that? So I could, for example, submit my money to a contract that in one side will get Ethereum and on the other side will get me Bitcoin, and that Bitcoin will be deposited to the account of yours. So these are transactions. When we talk about blocks, blocks are just buckets of transactions. And each transaction is cryptographically verified, and each block that wraps a lot of transactions is cryptographically verified. And as I said, the miners are responsible for actually solving a very complex mathematical puzzle in order to seal, in order to complete that block. Now, every block is actually containing the verification code of the previous block as part of its own content. And that's what makes the blockchain a chain of blocks. Because if every chain is sealed with no data of the previous block, we basically can reproduce any single block and exchange it without everyone notice. But when we talk about the chain, that block 0 verification code is part of block 1, and block 1's verification code is part of block 2, then we have a continuous chain that any change, if I want to, let's say we have a million blocks, and I want to change block number 100, I'll have to reproduce, which means I'll have to mine to recalculate the mathematical puzzle for all the blocks since block 10. So that's simply impossible. What is an account? So basically, in the blockchain world, we have different entities, different participants, different parties that are interacting with the blockchain. And an account could be what is called EOA, and a user, basically. So I can have a set of private key or a secured keys into an account, and nobody else know it. And I use this private key in order to sign every transaction and to authenticate myself against the network for everything that I do. Another kind of account is a contract account. Once a contract, smart contract, is a program that is being deployed to the chain, and once deployed, nobody can change it. It's there forever and ever, and if I want to change any of its logic, any of its state, to change its state, I'll have to run a transaction to execute a transaction, and in order to change the code, I cannot simply do that. The only thing I can do is deploy a new contract and maybe let other people that interact with that old contract the address of the new contract so that they can interact with the new contract. As I mentioned, Ethereum is the first launched programmable blockchain. And what is a token? So basically, in every blockchain, we have a native currency that is being used for the tokenomics of the blockchain. So for example, when we talk about Bitcoin, the unit of payment for miners, those that are running nodes in order to solve proof of work, solve a mathematical puzzle, they get paid by Bitcoin as well, okay? So once they gather those Bitcoin coins, native tokens, they can sell them on the free market, on the Bitcoin blockchain, and basically convert them to US dollar or just store them in the native token form. If you heard about ICOs, just like IPOs in the traditional world, ICOs were coin creation, coin way of funding using coins. So I can basically issue 1 million coins, and this would be sold to the public in order to raise money for my company. Few years back, we know about a lot of stories of ICOs, and basically all these ICOs, what are they? They are simply a smart contract that includes some total supply of a currency that I would call it whatever. Paraswap, for example, has its own currency, which is PSP. And with PSP, We try to get the community involved in the project and get refunded for gas, get benefits and rewards for using our platform, etc. So a coin could be native, the native coin that is being used for paying gas, etc. And it could be virtual, just a smart contract. Normally they are called ERC20. This is the standard that defines these kind of coins. And if you don't know, there are thousands, hundreds of thousands of coins right now in every chain. So if you heard of Ripple and if you heard of a lot of others, basically there are endless amount of different tokens that different companies and different parties are generating. If I would like to change between, to switch between these different tokens, I'll need a platform to do that. So I could use an exchange like in the traditional world when we have NASDAQ or New York Stock Exchange. They just manage an order book of bidders and sellers. In the decentralized world, there are smart contracts that do the same. They just maintain a list of order book, or they could even do a mathematical equation in order to, when you give me X amount of token X, I will give you Y amount of token Y. And all these DEXs are distributed across the network. And if I'm a player in this blockchain and I want to exchange one for the other, I will just have to look for all these contracts, and somebody needs to do that. And basically what PowerSwap is doing is scanning the entire chain for all the available DEXs, all the available pools, and finds you the best price for your swap from token A to token B. Let's talk about the data challenges for a blockchain. So first of all, the amount of data is immense. We are talking about terabytes of raw data that this data is encrypted, is not really understandable to the fullest. And this data is not full as well. So only part of the information is stored on that raw data. When we talk about I want to know all the transactions that I did, I'll have to iterate reverse way, iterate the entire blockchain and scan every single block and every single transaction in order to find all the transactions I was taking. Versus if I just want to know the balance, this is an easy task. So the data format that this raw data is stored is optimized for data appending, is optimized for easy verification of the data, but it's not optimized for analytics, for data science, for understanding the full information about the transaction. As I said, if I need to find all the transactions someone made, I'll have to reiterate the entire blockchain, and we're talking about tens of millions, hundreds of millions of blocks with trillions of transactions that I'll have to reiterate sequentially in order to find a piece of information. And of course, that's not very comfortable for data analytics. It's encoded. All the information is not simple as, you know, data sitting in our DBMS after data transformation that is very easy to query and very easy to achieve. Everything is encoded. I need to decode all this data. There are some additional ways to improve that data accessibility and queryability using logs and events. But logs and events in the chain are freestyled. I can decide of a log named whatever, and the information in it includes whatever, but it won't include a lot. It's eventually consistent because every block is mined and it takes time until I get all the transaction data to be finalized, to be secured. It's not explorable as I explained. It's centralization for public explorers. If I want to get the data, I can use some third-party analytic companies like Etherscan, if you heard, and those companies are simply centralized, so I cannot trust the data that they expose to me. If I want to know the reality, I really need to scan the blockchain itself. It's a big data. As I said, it's terabytes of data, just the raw data, and when decoded and fully enriched, it gets to hundreds of terabytes in order to get the full data properly. And it's not standardized. Every chain is a different story. Yeah, we have to cut, but I'll go quickly about the challenges. So reporting and notability and traceability. Prediction is a big thing. If I could, for example, predict what's going to happen for a price of a token, what's going to be the best token to invest in next, cyber protection, hacks that happen all the time, and decentralization. How do I verify that the network is really decentralized? So why do I think data science is very important? Adoption is skyrocketing. We're talking about governments. We're talking about federal banks that are exploring the blockchain technology and trying to see how it would fit. It's a multi-industry market. If we're talking about health, if we talk about finance, if we talk about different industries, there are endless challenges, and we need a fresh perspective. Some data scientists that come with experience and haven't seen blockchain and come with fresh mind. And it's definitely going to be the future technology, from banking to voting to any different application. So thank you very much.